Welcome, everybody. Thank you for joining this session. My name is Brice Pele, and today I will be talking about building real-time mobile and web applications with modern APIs. This presentation is part of our Modernization Track that covers modern compute, modern applications, modern DevOps, and management and governance. Some of the things that we're going to talk about today are, of course, why modernization? We're also going to cover GraphQL and AWS AppSync. We're going to talk about features and integrations and security that AWS AppSync provides, and then we'll take a closer look at real-time with subscriptions. Throughout the conversation, we'll also look at some of what our customers are doing with AppSync, and we'll, of course, dive into some demos. So the first question you may have is, why modernization? Why are we even talking about this? Well, if we take a step back, businesses are facing certain challenge when it comes to building apps and reaching their customers. They need to build efficient APIs that can go anywhere and meet their customers where they are. They need to be able to engage with customers. And sometimes this means delivering the right data at the right time. Customers need to be able to build reusable and scalable APIs. APIs that can connect multiple data sources and then be usable by multiple clients and serve multiple purposes. And last but not least, builders and customers need to be able to develop their applications faster. Time is always of the essence. Now, sometimes REST is just not enough to do these things. And that is where GraphQL comes in. So you may ask, what is GraphQL? We get that question a lot. So I think it might be good to take a step back and talk a little bit about what GraphQL is. Now, if you just go to graphql.org, you will see that GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. So 3 key pieces of information in that sentence. GraphQL allows you to describe your data, ask for what you want, and then get predictable results. So it's a different approach from what you're traditionally used to seeing with REST APIs. But let's talk a little bit about what it does. And sometimes it's easier to explain what GraphQL is by then just looking at a simple example. So let's take this scenario, for example, where we have an application that is running on a mobile phone and an application that is running on the desktop. Now, these are the same applications, but as you know, there's a smaller form factor on the mobile side, and on mobile side, can be roaming on to go, dealing with different network connections, right, and network connectivity. So typically, when you look at a mobile application versus something that's running on a desktop, your mobile application is going to want to optimize the performance for the platform and the real estate size. So there may be less amount of data that has to be fetched. If you look at how things work with your typical API endpoint, you're going to have 3 different data sources or 3 different type of objects that you want to retrieve. So that's why we have the green, the blue, and red here. So you may be getting something like comments, posts, and information about authors from your backend data sources. And you're interacting with 3 different APIs or 3 different endpoints because you have 3 different type of resources. You may be going to one database or be going to multiple databases, right? But you have these multiple endpoints. So in a REST environment with these typical traditional API endpoints, anytime you make a request, you're going to go to your first endpoint. So when I want to get the green data, I'm going to go to my green endpoint. And because this endpoint is not flexible, regardless of whether or not I want to get information from my mobile or from my desktop, which on my web browser, I am going to make the exact same request to my backend. So you can see that I have the mobile component that I'm fetching, and then I fetch a bit more for web, and then I end up overfetching. So I'm getting all of that payload sent back to my mobile and my laptop, even though I only needed parts of that data. And then I need to retrieve information from my second endpoint. And it might be here that my second endpoint relies on information from my first endpoint A, so that request has to be done in sequence after I've retrieved information from endpoint A. And here again, we go through the same thing. We have to get a whole bunch of data for both the mobile version and the web version of my application, which is not needed. So we're overfetching. And then we repeat that again for C. So not only have we spent a lot of time fetching this data because we're fetching it in sequence, we've also overfetched the amount of data that we need. So there's a lot of optimization that can be done here. This is definitely not super performant. Now, if you compare this to how GraphQL works, how a GraphQL endpoint works, with GraphQL, there is only one endpoint that you interact with, and that endpoint takes care of interacting with the different data sources in the backend. With GraphQL, you can also specify the data that you want to get back. Remember, we said you get what you request for. You specify the data that you request for, and you get just that. So my browser can make a specific request to the same endpoint to get a certain amount of information or a certain set of information, and my mobile fetching the exact same data, but with less information specified and required, can get the data that it needs. Now, the great thing about GraphQL is that it creates an abstraction layer. So your client does not need to worry about what's going on at the backend. Your GraphQL API could be retrieving data from any number of data sources, right? And microservices, as we see here. It could also be getting the data from a diverse set of data sources. So it could start by getting some data in a SQL relational database, could interact with a microservice to get some data, and then interact with a NoSQL database to get some data. This is something that is hidden from the client, and it makes it easy for the client to really focus on get me the data that I need and give it back to me in the format that I need. That is one of the main differentiators. It's more efficient, more performant, and there are less queries that have to be done because we're only doing a single query to our GraphQL endpoint to interact with those multiple data sources. With GraphQL, you get exactly the data you need, nothing more, nothing less. So we talked about GraphQL and we started saying, well, it's a query language for your API. So how does it do this? Well, GraphQL provides a set of components that allows you to define your data model, what we call your types, right? So it uses a schema definition language and provides a schema where you can specify your types. So for example, here you have a type post, and you can specify the fields and the type of those fields. And you see the exclamation mark behind, for example, the ID type or the string type. This specify that these fields are required. So you cannot create a post object without an ID title or author. So this allows us to be really specific about the type of data that we're storing and that we're specifying. And then you can define your operations. So you define your queries. Your queries are used to fetch data. Your mutations are used for changing, like creating, updating, or deleting data. And then your subscriptions. So subscriptions are a brand new concept that GraphQL introduces that is not really present with traditional REST endpoint. Subscriptions allows your clients to be notified for any mutations that is done via your GraphQL endpoint. So any changes that is done via your GraphQL endpoint, your clients can be notified. And if you think about that, it opens up the door for a lot of different use cases and a lot of different implementations. So if we look at it a bit more closely, we have our queries, mutations, and subscriptions. When we do our queries, you see these blue boxes here. These are called the selection set. This is what allows us to specify the data that we want to get back in our operations. And you have the possibility to be pretty specific with what you want to get back. For my query, I may want to only get back the ID or title. And for my mutation, after something is created, maybe I only want to get back the ID and date. So this is the flexibility that you get, and it allows you to really be specific about the data that you're getting back and optimize for your specific use case. Now, we talked about the fact that it's a query language for your APIs. So GraphQL is a specification. It defines how you should use the SDL to define how you then interact with types. But that's what it is. It doesn't provide a runtime. So now that you want to use GraphQL, you do need that runtime that you're going to be able to interact with to get that data, right? And so here you have a couple of options. Well, you could decide to run your own GraphQL endpoint. Maybe you're going to run this on a server somewhere, right? You could roll up your own. But there's a lot of undifferentiated heavy lifting that goes in with that. This is where AWS AppSync comes in. AppSync allows you to build scalable applications on a range of database sources, including those requiring real-time updates and offline data access. So AppSync is a fully compliant GraphQL endpoint that allows you to interact with resources in your account. And it allows you to move quickly. So how does AppSync work? Well, AppSync really just allows you to connect multiple types and different type of applications to your data sources. We're seeing customers use AppSync to implement enterprise applications, web or mobile application, real-time dashboards, IoT application, and then implement things like offline and Delta syncs, things that are really difficult to do when you need to roll up your own endpoint or when you're using traditional endpoints. So we are seeing customers really innovating at a rapid pace using AppSync. Customers like CookPad. CookPad is a customer that offers live shows, right, that are put on by famous chefs and celebrities, and they use AppSync to engage and interact with their customers during live broadcasts. Customers can interact, chat, like content, and provide comments. So AppSync is really helping CookPad move quickly and engage with their customers. So let's take a look at what the type of things that you can do with AppSync. So we talked about engaging with customers and doing chat. Let's dive into a demo that kind of shows you the type of things that you can do with AppSync when it comes to chatting. Okay, so I have an application open. I have 3 windows open, just to be clear, right? This is a chat application that I have up and running. You see that I'm logged in here on the side as Brice, so I'm logged in as myself. I have another user here logged in, Selwa, and I have Stefan logged in on the side. So building a chat application can be pretty complicated because there's a real-time component to it. When you interact with somebody over chat, that person typically wants to be able to see what is going on and get those real-time notifications for chats that are coming in. That can be pretty complex to do. Let's see how this application works. This is an application built with AppSync. Just going to refresh this screen, and you can see that all the users are here. So I'm going to start a new chat conversation. So as you can see here, I'm logged in on the side here, and I'm going to initiate a chat. Now, as soon as that's done, you can see that something happened here. We have a direct chat now that shows up on the server. I haven't opened this chat on this side, but I can send a new message. Trying to type something funny here. So I send that message, and you can see that I've gotten a notification here. And I get another notification. Now I can go back on this middle area, and I see the same thing here. Let me send a message back. And you immediately see the message back here. Okay, so let's dive into this. Let's look at what's going on behind the scenes. So I'm going to open my developer console here, and I'm going to quickly refresh the screen so that we can see everything that's going on here. So as you can see, if I send another message, again, I'll send a message from this screen. You see that I'm getting the notification, but there's no polling going on here. Polling is pretty expensive and inefficient. There's no polling going on here. What's going on is that we've got a WebSocket set up that is listening for messages. This is the subscriptions that we mentioned earlier. So subscriptions allows clients to receive notification for any mutation that is happening in the system. So in this system, I've created a message using a mutation, and when the mutation is performed, a subscription is triggered. So you can see here that I have a subscription that was triggered and that sent payload, right? So you can see that I updated my conversation, for example, with the information about the ID, but I also got information about the last message that I received. So here you can see that I got a message from Serwa. We scoot that up a little bit, and you can see that the content was hello. So this is how I'm able to get this notification sent from one chatter to another person. So this works for one-to-one, but does it also work for one-to-many? Well, let's try this out. I can come in here and create a new chat group. I'm just going to invite a whole bunch of folks to this chat room and keep an eye on this again. You've got my direct chats, and then I click create. And you can see immediately that the family chat room appears over here. And then let me try to send a message. So you can see the family chat room here, and I say start of a new chat. And immediately I get the notification at both places. And if I go in here, I also have the notification. And we can then do interesting things like when we build chat system, we want to be able to send images. So we can say, this is how AppSync works. So you notice that my message appears here first with no image. So that's kind of interesting, right? And then I see the image appearing here, right? We seem to have a bit of an error loading to image on this side. But I can not only get messages and notifications about new messages, I can also get notifications on when messages are updated. So what happened on this side is that I sent the message with a attached picture. The picture was processed by Lambda into background after it was put in an S3 bucket and was turned into a thumbnail. So easier to download a thumbnail in your application. And once the thumbnail is created, the message is then updated with information about the thumbnail so that the thumbnail can be shown on the screen. So mutations, subscriptions are really flexible, and you can build really intricate systems based on AWS AppSync. Let's go back to the presentation. So to dive into what we just saw, this was a chat API, a chat application. And this is an overview of the chat API architecture. It's a bit simplified, but it gets you a good idea of what is going on here. We have an application that is interacting with our chat API. This is AppSync. Our application is getting queries and pushing mutations and receiving subscriptions. With AppSync, we can interact with our DynamoDB table. This is where we're storing our information. So we have our messages, our user conversations, our users, all of this stored in DynamoDB. And we can also create complex systems by using things like DynamoDB streams that then calls a Lambda function and then allows us to update information in our tables via AppSync. When this information is updated, we then trigger a subscription. We can do interesting things like using AppSync to get signed policies to access our images in our CloudFront distribution, right? We can use user pool to trigger a Lambda function to update information in AppSync. So AppSync really becomes the central nervous system of our application, allows us to build an application that scales and that sends real-time notifications to our users and clients. Okay, so let's go back to how AppSync works. I think we talked about the fact that AppSync can allow you to connect multiple types of applications. Now, the other part of what we talked about when it comes to GraphQL was using your existing data, right? And this is really important. AppSync allows you to connect to multiple data sources in your account and in your on-prem environment. You can connect it to things like Amazon DynamoDB, Amazon Aurora, Elasticsearch, AWS Lambda, and you can use it to connect to any HTTP endpoint that is available. And these HTTP endpoints also includes AWS services. So using HTTP endpoint, you can connect to any AWS service. AWS AppSync can be configured with IAM roles that it will then use to sign requests that you send to AWS services. So that's pretty interesting and pretty cool. Now, when we look at the GraphQL aspect of it, in AWS AppSync, we have a schema. This is where everything starts, the data model where we specify our data types and our operations. Our operations that we define in our schema are then linked to resolvers. So you can think of resolvers as the glue to business logic that allows you to tie your schema types and operations to your data sources. So your resolvers are the glue between your data sources and your schema. There's multiple types of resolvers that we support. We just talked about the first type of resolvers, which were unit resolvers. Unit resolvers allows you to access a single data source in a request. But we also have pipeline resolvers. And pipeline resolvers are neat in the way that they allow you to access multiple data sources in a single request. So with a pipeline resolver, you could access a SQL database, get some information from that SQL database. Based on that information, fetch some more information from a NoSQL database, and then maybe interact with a Lambda function to augment or decorate that data before sending it back to your application. So pipeline resolvers allows you to access multiple data sources in sequence in a single request. So there's no more back and forth between you, your application, your client application, and your backend. We also have the concept of direct Lambda resolvers. So there are situations where you may want to interact directly with an AWS Lambda function, right? At this point, you're using the Lambda function to not only fetch data, you're also using it to implement your business logic. So when this happens, you actually don't need to implement a resolver. You simply can tie your Lambda function directly to your AppSync API. So there's no resolver to write, and you can move all of your business logic to your Lambda function. Now, we talked about AppSync. AppSync is an AWS service, and AppSync is built using best-in-class enterprise-grade security best practices. One of the things that it really focuses on is making sure that you can use AppSync with multiple type of clients. So AppSync makes it possible to access it using different type of authorization modes, right? And this allows you to connect different type of applications, different type of resources to AppSync. You can use API keys to connect to your application. When your user uses Amazon Cognito user pools into client to sign in, you can use tokens from Amazon Cognito user pool to authorize requests towards AppSync. You can do the same thing when you're using OpenID Connect. You can use the JWT tokens returned by the IDP to authorize request. For your backend services, things like Lambda function or EC2 instances, you can use IAM to sign requests that are sent to AppSync and authorize them in that way. And you can also use AWS Lambda functions in a pipeline resolver to implement custom business authorization logic. So if you have very specific use cases, you can put a Lambda function in front of your resolvers in your pipeline resolver to implement custom authorization. And if you don't want to authorize a specific user, you can bail out of the pipeline early by just specifying that the request is not authorized. And so this is something that we are thinking about quite a bit. So stay tuned for more developments around custom authorization using AWS Lambda. So how does this work? Well, let's take an example where you have a flight, for example, right? And you have a flight type that has been accessed maybe by customers that are signing into an application with Cognito user pool. So with these customers, they are part of a frequent flyers group, and we want them to access all of the data for a flight, right? They're our valued customers. We want them to access all of that information. But maybe you have users that have not signed in using an API key, and you simply want them to be able to get information about the airport code and the airport name. Well, you can do that. You can mix and match the different access patterns. Maybe you have a Lambda function that's using IAM, and you want it to be access the airport information, the airport code, the name, the city, and locale, right? So you can do that as well. So you don't have to deploy multiple APIs to meet the needs of different type of AppSync users. You can use multiple authorization modes within one API and on one type. Let's talk about real-time GraphQL subscriptions. So I mentioned that in the beginning that subscriptions are triggered when a mutation is processed in the AWS AppSync system. So this is how it works. Your client subscribes to subscriptions. You can see here, subscription on create order, send me back the information that was created, right, when the order was processed. So you subscribe to this subscription, and then your client sets up a pure WebSocket connection, secure WebSocket connection with AWS AppSync. So this is a WebSocket connection that is set up once, right? So there's no overhead. You set up the connection once, and then you reuse that connection for multiple subscriptions. So you can have multiple subscriptions set up in your WebSocket. And then anytime a mutation is done, the subscription is triggered, and you get that instant notification over to WebSocket. And this allows you to do multiple things with WebSockets. We looked at the real-time situation with the chat application. But we have other customers like Sky Italia, that again are using AppSync to innovate at a really quick pace. And they're using AppSync to deploy their web components. And they're using AppSync to decrease the time needed to propagate real-time game data from a few minutes to milliseconds. And they've accomplished that by using subscriptions with AWS AppSync. The other thing to note is that by using AppSync, they were able to reduce their cost by a factor of 15. Now, that's definitely impressive. So these are scenarios that you definitely run into. And I think it's worth diving a little bit more and looking at a demo that showcases how you can use AppSync to actually power a real-time sports dashboard. So let's take a look at that. Okay, so here's the dashboard. It shows today's games, and I'm going to refresh it. Currently, there's nothing going on here. So I am showing today's games. So this is a dashboard. It's running locally, but this is a dashboard that would show you the games that are going on today. Let me refresh this. So there's nothing going on here. One of the things that you'll observe when I see this, as I show this, we've got a WebSocket set up. And again, we can look at the messages in here. So we've connected, and right now this WebSocket is subscribing to onCreate game event subscription with no variables. So it's essentially listening for any onCreate game event mutation. So what I'm going to do now is generate some data, and let's see what happens here. So I'm going to go in my AWS console, and I've got a nifty Lambda function that I'm going to just trigger by using a test. And this is going to trigger a whole bunch of things. So first thing I'm going to do, I'm going to go back to my application, and I'm going to refresh the screen. So immediately, you can see that we've got a couple of games going on. And if we just stay on this page and watch for a second, I'll go back to my messages in my WebSocket. You see that I've got the subscription set up, and you can see that the subscription is getting messages, right? So the last one we got was this one. You can see that there's a whole bunch of game information here, and we're getting more and more of these messages. So again, there is no polling going on. We are just getting these messages as they are being sent in. And the interesting thing about here is that we can use multiple components to assemble this architecture. So our data right now, if you look at this, is coming in through Kinesis data stream. So Kinesis allows us to ingest data, to ingest big data and to ingest a lot of data. So we can get that into our backend systems. But sometimes it's really difficult to then push that data to our front-end applications, right? And this is really where AppSync comes in. Because when that data is received from Kinesis, Kinesis then triggers a Lambda function, and the Lambda function then pushes that data via a mutation to our clients by using AppSync. Let's jump into one of these games. So right now you can see that all of the games are being updated. So this is pretty cool. On one dashboard, we're getting all the notifications that we need. But we can jump into this game. So these are, this is dummy data. So this is just for the demo. But you can see that we're looking at a game between the San Francisco 49ers and the Seattle Seahawks. And we're seeing all of the data here. As I clicked into the page, first of all, I see all of the events that have happened in the past, right? So that's the first thing. When I get into the page, you can see that I make a GraphQL query request. And if I look at the request, the response, I'm getting all of the information about the game with all of the events. So this allows me to show all of the events that have already happened. But then I'll also have my WebSocket set up. So let's look at the messages in my WebSocket. One thing to pay attention to in the WebSocket is that our subscription is a bit different. It's the same subscription for onCreate game event. But if you scroll down here, you can see that we specified the game ID. So now we're being a bit granular with the subscription, right? Subscriptions allows us to get the data that we need. We don't have to get all of the data that's being processed through the system. Here, we're on a page about a specific game, so we only need to show data about a specific game. So by specifying the game ID, AppSync will only send events that are related to this specific game ID. So that is a really efficient way of pushing data to your client. And you can see that the data keeps on getting pushed. So this is a pretty interesting way of using AppSync and creating a real-time dashboard. No polling, so it is not a heavy load on your system, right? You can actually scale back some of those systems that were continuously being polled and use something like AppSync to use a push model to send the data to your clients. Let's go back to the presentation and take a closer look at what the architecture looks like. So let's take some time to look at this. So this implementation is based on the real-time last sports update using AWS AppSync. And this is a solution that we have. You can go into our solutions on our solutions page on AWS, on our AWS public website, and look up this solution. But this is a solution that you can use to actually push real-time data to your clients that is coming from literally anywhere, right? And if you look at how it works, the point of entry is really Kinesis. So you could have something like a step function producing data. This is what we did in the demo. We have a step function that just is continuously producing data and creating a Lambda function that puts data into a Kinesis data streams. But if you think about it, the data could be coming from a third party, or it could be coming from an API gateway as well. When an event is put into Kinesis data stream, Kinesis uses the fan out procedure to trigger an AWS Lambda function. The Lambda function puts the data, reads the configuration from a DynamoDB table, and then essentially does a mutation on AWS AppSync. Now, AWS AppSync is going to save that event into a DynamoDB table, and then this allows us to easily query for that data once we pull up the information about the game. So we may be coming to our dashboard later when the game is over, and we still want to see the sequence of events. Well, at that point, we don't want to get it from our Kinesis data stream. We want to get it from an Amazon DynamoDB table, so we're putting it there. But as AWS AppSync does that, the mutation also triggers information, triggers the subscription that is then sent to our client that are listening for those subscriptions. So this is an architecture that could be applied to a lot of different things, but I love the way that the Kinesis data stream here is being used to push data into AWS AppSync, which then pushes it to your clients. Let's dive into how subscriptions work a bit more. When you have your clients that come online and that connect to AppSync, as we discussed, they use secure WebSockets to connect to AppSync. Now, let's say one of your clients does a mutation. It goes to AppSync. AppSync does a put item operation on your DynamoDB table, and then this triggers a subscription. Now, as we saw, subscriptions don't necessarily need to be sent to all clients. Your clients can choose to subscribe to specific changes that are going on in the system. So in this case, the subscription is only sent to our 3 clients, or if the subscription was only of interest to a specific client, it is sent to that client. Now, subscriptions don't have to be triggered by front-end clients. You can also trigger subscriptions from just about anything. So here we can use an AWS Lambda function, similarly to what we did in the demo, where you have a Lambda function that is creating the mutation for the game event. We then do the put item operation, and again, we push the subscription to our users. We can also have out-of-band requests. So something that does a change directly to your DynamoDB table. The DynamoDB table can then create a DynamoDB stream event that pushes the data to an AWS Lambda function, and then the AWS Lambda function can do a mutation against a local resolver. So a local resolver is a concept that you can use to push data to your clients without really writing the data anywhere, right? So here, we're only interested in pushing data to our clients, so we don't need to write it anywhere. We use the local resolver, and that pushes the information to our clients. So that's another way to go about it. So there are really a lot of different ways to push data to clients. Now, when it comes to AppSync, it's not just that AppSync allows you to create these subscriptions, right? AppSync subscriptions allows you to not deal with a lot of the overhead that comes with actually implementing WebSockets and monitoring WebSockets. AppSync takes care of the connection management. So there's no connection IDs and tables to manage for each WebSocket. You don't have to worry about scale. The subscription will scale to millions of clients. AppSync will take care of the fan out, and you can use it to do things like broadcasting one-to-many or direct one-to-one type of messaging. And then we have a wide array of metrics that you can use to actually monitor the performance and the health of your subscriptions. Now, we have a lot of customers across multiple industries that are using AppSync to implement and iterate quickly. Customers like BMW that are using AppSync to create a scalable and universal API for data providers. Customers like Peacock that launched a streaming service that has over 26 million signups. And they are using GraphQL APIs provided by AppSync to develop applications faster. Or customers like Aldo in retail that focus on implementing features in their application instead of managing their system and its infrastructure. So they're using AppSync to iterate quickly and to implement applications quickly. Now, talking about universal APIs, let's take a look at another way that you can use AppSync to connect multiple data sources. So let's look at this demo. So this is an interesting demo. So this is an application that uses AppSync to initiate queries towards Athena, right? AWS Athena is a service that you can use to run ad hoc queries against big data sets. And so this application allows clients and developers that may not know a ton about interacting with Athena to actually start queries and retrieve data from queries. So in this specific example here, this application is interacting with a data set that provides information about population density across multiple countries. And what this is doing is it's retrieving this information and creating bins of data across longitudes. So for example, we're looking at Cameroon here, and we're seeing the bins of population density across multiple longitudes. And the thing that is striking here is you can see that across like the 9 to 10th longitudes, we've got a lot of samples of populations, right? This kind of indicates that you have population centers around these longitudes. We can take a look at other areas. For example, this is Egypt, and you can see that around this longitude, we have large samples of populations. And this is actually surrounding the Nile River. So around the Nile River, we have a lot of samples of populations and samples of a large size, right? So we've got a lot of population here. But let's take a look at how this actually works, right? With AppSync. So I'm going to refresh this so that we can get all of our network stuff set up here. Let me start a new query. So for example, let's say we wanted to see information about Brazil, right? So this is going to start a query. And as you can see, once the query is started, we then use a subscription to get notified on when our query is ready. Because things that we're fetching from Athena, it's big data, it's a big data set. It can take actually a long time to run that query and to get the information back. So instead of polling the system, we are actually just creating a subscription and using the subscription to get notified of when the data set is going to be ready to be fetched. So you can see here that we're still waiting, and this might take a little bit as the data is being fetched. And while that is going on, we can actually take a look at how this looks in Amazon Athena. So we can come back here to this console, and this is what you would essentially see. This is the query that is being run to get the data. Now, your developers may not know anything about this, right? This is a level of complexity that your developers may not be familiar with. But by using something like AppSync, we can actually create these layers of abstraction so that your clients and your developers do not need to directly know about creating these queries to access the data. All they need to know is how to interact with AppSync to access the data. So let's go back to our application, and you can see that the data was returned. And we actually can look at what happened. We had the query, and we got the payload back. Let's see here if we can see the data that was sent, right? And you can see here we got the operation was on update Athena operation. We got the query that was run. We got the country code. We got the owner. And we get the status completed. So once this is done, our operation then can go fetch this data from an S3 bucket, and we're using some JavaScript libraries to display the information, right? So not only are we interacting with Athena, we're also interacting with S3, and then we're saving the results of these operations in a DynamoDB table, so that if we need to go and access this data later, we have access to the data, and we're doing all of this via AppSync. So this is another way that we can create these kind of universal APIs that allows us to connect multiple data sources. Okay, so let's go back to the presentation, and you can see how this works here. This is an Orchestration API example. So our application only interacts with AWS AppSync. AWS AppSync then takes care of interacting with DynamoDB, Amazon Athena, and AWS Lambda. So we're abstracting all of this backend and allowing our clients to only focus on interacting with AppSync. So you can see that our client authenticates, then starts a query with AppSync. AppSync then interacts using an HTTP resolver that we saw earlier, interacts with Amazon Athena, and then Amazon Athena processes the information, stores it in an S3 bucket, and when the data is ready, the S3 bucket triggers an event. This is an S3 put event that triggers an AWS Lambda function, and then the AWS Lambda function simply updates the operation that it was saved in DynamoDB via AppSync. So this is done via mutation, and because of that mutation, we get this on update Athena operation sent back to the client, which can then go ahead and query the result file and show the data on the screen. So this is another way that you can create these orchestration universal APIs with AppSync. Now, AppSync provides you the backend infrastructure, the backend service that you can use to use GraphQL to interact with your data sources. On the front end, there are multiple clients that we provide and implementations that we provide that you can actually use to connect to AppSync. You can use something like AWS Amplified Data Store. Now, if you've got a use case where you're trying to implement a local store and you're trying to implement offline capabilities, Amplified Data Store is the client that you want to use. You can use our AWS AppSync SDKs as well if you want to have a local cache, right? And if you want to use like native applications, things like React Native, iOS, and Android, and you want to use a different type of programming model, you can use the AppSync SDKs. In situations where you need something that's more custom, maybe you're implementing something on a platform where we do not have support for the programming language, you can actually write your own custom implementation. You can write your own custom implementation that will allow you to query and do mutations. And we also provide guidelines that you can follow to write your own WebSocket client. So you can really use AppSync on any platform and in any type of application by using these different options. So as we covered, AppSync is much more than just a GraphQL service. It is an API data service that allows you to connect your applications to your data sources. You can connect any type of application to any type of data source. You can get started easily. There's a serverless service, so there's no infrastructure to manage, and it scales with your usage. Use it to unify your your data sources, right? Your data layer, and create those abstractions. You can use the Amplify framework to get started, to use things like data store, to use the GraphQL transform, to use local mocking, and to use CodeGen. But you can also use things like the AWS CDK for that allows you to use a schema first or code first approach. You can use things like CloudFormation. You can use multiple different CI/CD and infrastructure as code tools to implement your AppSync backend. I definitely encourage you to visit our resources to learn more about AppSync, learn more about the community, and to learn more about how to get started. I want to thank you for joining this session that was part of the Modernization Track. We focused on how to build real-time APIs and modernizing your APIs using AWS AppSync. I hope you enjoyed this presentation. My name is Brice Perret. Thank you very much for joining this session.